Guten Abend. Good morning. To stem off of yesterday, we're going to focus on today another special right triangle, which is a 45, 45, 90 triangle. And I'm going to do these three examples with you to show you how similar they are to what we did yesterday with 30, 60, 90 triangles. So, first things first, I got a 45, 45, 90 triangle. And our foundation of how to figure this out, well, this is always x, x, and this is x radical 2. Now, like we did yesterday, there was a proof about how we figured that out because in a 30, 60, 90 triangle, remember, in a 30, 60, 90 triangle, 30, 60, 90 triangle, we knew that this was always x, 2x, and x radical 3. Now, we did a proof yesterday because I showed you guys yesterday that an equilateral triangle, a 30, 60, 90 triangle was just a equilateral triangle that was cut in half, which is why we always knew they always cut the leg in half, which is why this is this, and we did the Pythagorean theorem to prove that this is always x radical 3. And I'll do the same with you guys right now to prove that this will always work out because a 45, 45, 90 triangle is simply a square that's cut in half down the middle. So we know for a fact that this is a isosceles triangle, always, for these 45, 45, 90 triangles. So, for instance, if I'm given the side length of a square being, let's say it's 6, okay? Let's say x equals 6. Well, by using the Pythagorean theorem, we know, first of all, this is an isosceles. This is also equal to 6. So watch us get this be equal to 6 radical 2. And here's how you do it. 6 squared plus 6 squared equals c squared. 36 plus 36 equals c squared. 72 equals c squared. Square root of 72. Well, there's a 36 and a 2 inside of 72. And I get a 6 radical 2 equals c. Like I told you, that's how it would work out every time you can do this. Now I got some different examples here we're going to run through right now and work out how to work through them. Okay? So, here we go. Now remember, keep this in your notes. You can always reference this, and this only works for a 45, 45, 90 triangle. Nothing else. We got x, x, and x radical 2. Alright, well the first one's pretty simple because we're given 3 here. I want you guys to find this length, so we know this is 45 and 45. Well, by rule, these are isosceles, so this has to be 3, and this has to be 3 radical 2. Okay? Number 2 is right here, and this one says we got 4 radical 2, we got y, and we got x. Now, yes, it is as easy as knowing that this is equal to this. So we know that this is going to equal 4 because this coefficient will do that. More importantly, let's think about this mathematically because it's going to get more challenging later on, but I want you to know this. Remember, this is equal to x radical 2. So what I want to do is I want to solve for x. And this is what I'm trying to embed this process in your head. You guys can all see this. I think you can. All you do is divide both sides by radical 2. Okay? So now we can solve for x. When you divide both sides by radical 2, these things cancel off, and you're left with 4. Hence why you know this is the case. Please remember this process because it's imperative to understand, because now the next one gets a little trickier. Okay? The next one says, we got right here, I'll do this a little bigger so you guys can see this. I know this is 45, 45, 90. And I'm giving this as 10, and I got to find these missing side lengths. Well, I got to solve for x. So this is why I always embed the process with you. So we know that this is supposed to equal to x radical 2. Well, I got to solve for x. Okay, so let's do this work over here. 10 equals x radical 2. I've got to solve for x. So I divide both sides by radical 2. So now x equals 10 over radical 2. But like we learned previously to this is improper because I cannot have a radical in my denominator. So I'm going to multiply that radical out, and I'm going to get 10 radical 2 all over 2, which this simplifies one more step. 10 over 2 reduces to 5 radical 2 equals x. So now we got our, there we go, and 5 radical 2. It says, simple as that. Trust the process, never fail the process. I will see you guys all in class, and we'll go over a lot more examples, but this is a good tutorial. Take notes, ask questions. See you guys in class.